Welcome back. This is Problems About Sequence. Is lesson 16, and we are going to solve these 11 problems about sequence. First, let's go to review what is a sequence. A sequence is a collection of numbers, A1, A2, A3, AN. Maybe this collection never stops. AN plus 1, AN plus 2, etc., etc., and you keep going. It's a collection of numbers. These numbers are generated by a function that for every n in the natural number, we assign f of n. We assign a1, an, an. For example, from the natural to the real, we assign a number. For example, let's say that we take the natural number, the 1, the 2, and the 3, and we'll assign the real number, the 2, the 4, and the 6. So the a sub n will be 2 times n. So a 1 will be 2 times n equal 1. So it will be the 2. A2 will be 2 times the 2, n equal 2, so it will be the 4. So in this way you visualize a sequence, so you may visualize also the sequence like this. These are the two ways to visualize the sequence. So I will put the n here, and I will put all the a's here. So when n equal 1, a1 is 2. So this is 2. When a equal 2, a2 is 4. When n equals 3, a3 is 6, etc., etc. So it's a collection of numbers, and the numbers is this a1, a2, and a3. The other way to see this number is by visualizing how they jump into the real numbers. So this is the real axis. This is the x-axis. This is the 0. This is the 1. This is the 2. This is the 3. This is pi. This is pi. This is the 4. This is a square root of 2. So how the sequence a sub n equal 1 divided by n is moving. So when n equal 1, a1 equal 1 divided by 1, so it's 1. When n equal 2, a2 is equal 1 divided by 2, which is 1 half. So the sequence starts here at 1. Now the sequence moves, the point moves to 1 half. Later on, the point moves to 1/3. Later on, the point moves to 1/4. Later on, so you see the jumping of every term of the sequence, how it will go. It will run from 1, and it will run in this direction. So the question here is, a sub n will converge to a number? It seems that a sub n will converge to 0 in these examples. Okay, let's go to do problems. So in this problem, we practice writing terms of a sequence. So if they give us a sequence like a sub n equal 3 raised to the n divided by n factorial, who is a1, who is a2, who is a2, a3? a1 is when n equal 1. When n equal 1, I generate a1. Well, it will be 3 raised to 1 because n equal 1 divided by 1 factorial. So a1 would be 3. Who would be a2? a2 will be 3 raised to the 2 powers, second power, 3 squared divided by 2 factorial. 3 squared divided by 2 factorial is 9 half. What is n3? A4. A4 is 3 raised to the 4 divided by 4 factorial. 3 raised to the 4 is 81. 3 by 3 by 3 by 3. Divide by 4 factorial. 4 multiply by 3, multiply by 2, multiply by 1. 81 by 24. So the idea is to visualize how they move the points. So the point start at 3 is going, so the point start at 3 here at this point at 3. Later on, A2 goes to 9 half. 9 half, so the point start here at 3. 9 half is 4.5, is go to here. A3 is 26 divided by 6. Who is 26 divided by 6? 26 divided by 6 is 9 half, so it stay here. So A1 is here. A2 is here. A3 is also here. A2 equal A3. A4 is 27 divided by 8. Is like 3 point something. So A4, it will be here. So it will jump to here. A4. And A5 will jump to almost 2. So A5 will jump like this. This is A5. So the question is AN, to where it will go. AN, I think that when n goes to infinity, n factorial will be make, when n goes to infinity, 3 raised to the n will go to infinity, and n factorial will go to infinity, and a sub n will go to 0. You can see these things. You can see here these things. 3 to the n is smaller than n factorial for certain n. So 3 to the n divided by n factorial will be smaller than 1. Okay, how you see that 3 to the n is smaller than n factorial? Let's say 3 is bigger than 1 factorial. 3 squared is bigger than 2 factorial. Now 3 cubed is also bigger than 3 factorial, because 3 cubed is 3 by 3 by 3. This is bigger than 3 factorial, which is 3 multiplied by 2. This 3 is equal to this 3, but this 3 is bigger than this 2. So 3 factorial is bigger than, 3 raised to the power 3 is bigger than 3 factorial. But it happens in n when the sign of the inequality change. For example, for n equal 10, 3 10, it means 3 by 3 by 3 tenths times. 3, 3, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 times. Now, this is 3 to the 10. Now, 3 to the 10 will become smaller than 10 factorial. Why? Because 10 factorial means 10 multiplied by 9, by 8, by 7, by 6. Because this number, the 10, is bigger than this 3. The 9 is bigger than this 3. The 8 is bigger than this 3. The 7 is bigger than the 3, etc. 10 factorial will be bigger than 3 to the 10. So in general, 10 factorial will be bigger. So in general, n factorial for certain n factorial will be bigger than 3 raised to the n power. So 3 to the n divided by n factorial will be smaller, approaching 0. is smaller than 1, approaches 0. So if we write the first terms, we see the 3 start here at the red points. Now the next point is 9/2. It will jump to 9/2, A2. A3 will stay here at 9/2. Now A4 will go to almost 3 point something. Well, it will be here. And A4, it is 27 divided by 8 is A4 is here, sorry, A4 is here, and A5 will go to almost 2, A5 will go here. It will be jumping and jumping and jumping and jumping, and we expect that after many, many ends, we are approaching the 0. Okay, so we wrote the first 5 terms of the sequence that this is what they are asking. Let's go to the next problem. Next problem say, write the first 5 terms of this sequence. This sequence change the sign when n changes. For example, for n equal 1, it will be 1 plus 1, 2 minus 1 squared will be positive. So because n is 1, here will appear an 1, so the a sub 1 will be 2. A sub 1 is 2. For n equal 2, 2 plus 1 will be 3 minus 1 raised to the power 3 is negative, is minus 1, so it will be 2 divided by 2 minus 2 divided by 2. For n equal 3, you will obtain positive 2/3. For for n equal 4 minus 2/4, which is minus 1/2. A5 2/5. So the sequence will do like this. It starts at 2, it starts here, it will go to minus 1, from minus 1 will go to 2/3, from 2/3 will go to minus 2/4, minus 1/2, from minus 1/2 will go to 2/5, and it will go to oscillating around the 0. Okay, let's go to the next problem. Problem it say, find is the same problem, it's the same find the 5 terms, but now the sequence is different. The sequence is a sub n equal sine n pi divided by 2. Now the third problem says write the first 5 terms of this sequence. The sequence is a sub n psi is equal to sine n pi divided by 2. If n is 1, it will be sine of 1 multiplied by pi divided by 2, or sine of pi divided by 2, or 1. When n is 2, it will be sine of 2 pi divided by 2, which is sine of pi. Sine of pi is minus 1. When n equals 3, it will be sine of 3 pi divided by 2, which is minus 1. So the sequence will do a1 equal 1, a2 equals 0, a3 minus 1, a4 equals 0. In our picture will be, you start at 1, a1, a2 goes to 0, a3 goes to minus 1, a4 goes to 0, so a4 will be here at 0, a5 goes to 1, and a6 goes to 0. And it's a cycle. It's a cycle where the terms is doing like this, is jumping like this. Chuk, 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 chuk. It's starting to be a cycle where they repeat. Do you see that it will end in any particular point? No. So do you think it will have any limit a sub n? No, because it's all the time changing. It's not approaching any fixed point, any limits. Let's go to the next problem. Problem say, Find the limit is possible of the sequence 8n cubed divided by 2 minus n cubed. So what it says, find the limit when n goes to infinity, the limit when n goes to infinity of 8 times n cubed when n is very, very big, divided by 2 times minus n cubed. How do we find this limit when n goes to infinity? When n is very, very big, to what it will tend this ratio? Well, to do this, we'll make the limit when n goes to infinity, so we divide numerator and denominator by n cubed. So if we divide numerator and denominator by n cubed, minus n cubed divided by n cubed, we know that the numerator, the n cubed, will cancel with the n cubed here, so the numerator will tend to 8. The denominator will tend to 0. 2 divided by n cubed when n goes to infinity will tend to 0, and this will tend to minus 1, so the limit will tend to minus 8. Let's go to the next problem. This is again to practice the same skill to find the limit. So we take the limit when n goes to infinity of the ratio of 2n divided by the square root of n squared plus 1. So if we divide by n the numerator and the denominator, we didn't do any change. So to divide inside the square root, we need to divide by n, but because it's inside of the root, we need to divide by n squared, divide by n squared. And now the limit is this n will cancel with this n squared will cancel with this n squared, so it will be 1. So this will be 1 divided by the square root of 1 plus, when n goes to infinity, 1 divided by n squared will go to 0. So the limit will be 1 divided by square root of 1, with this 2 times 1 divided by 1, n divided by n, 2 times 1, so divide by square root of 1, which is 2. And this is the limit. Let's go to the next problem. Find the limit of the sequence 1 plus minus 1 to the n. So if you put it in the rectilinear line, the first term is when n equal 1. When n equal 1 is minus 1, this term, minus 1, so it will be 1 minus 1 will be 0. So the terms will go at the 0, a1, a2 will be 2, a2, a3 will be 0, a3, a4 will be 2, and so the sequence, the point of the sequence starts here, it jumps to a2, from a2 it jumps to a1, from a1 it jumps to a3. Do you think they have a limit? It never stopping up. It never approached to a fixed point. So it doesn't have a limit, so the sequence diverge. Let's go to the next problem. Find the limits of a sub n. So the same idea, if you plug in for different n, you will obtain the different terms of the sequence, which will 0, 1, 0, 1 half, 0, 1 third, 0, 1 fourth, 0, 1 fifth. You think that it will converge? So let's go to right to make a picture of this. So it starts with 0, and this is the 1. From 0 to 1. From 1 to 0 again. Now from another 0 to 1 half. from 1/2 to 0 again. Now from 0 to 1/3. 1/3. From 1/3 to 0 again. Now from 0 to 1/4. From 1/4 to 0. So after infinity jumps, the term a sub n will end at 0, so it will converge to 0. Okay, now find the limits of 1 plus 3 divided by n raised to the power n. This is the number e that is hidden here. So let's go to manipulate this expression. The limit when n goes to infinity of a sub n, which number will discover that is? So is the limit when n goes to infinity of 1 plus 3 divided by n raised to the power n. So what we will do here is we'll divide the exponent by 3 and multiply by 3 and nothing will be altered. So limits. When n goes, we will remember these things. The limit, let's go to right here. The limit to remember. When n goes to infinity of 1 plus 1 divided by n raised to the power n, this is the number e. You can plug in numbers here. You can plug in, for example, 1 million. So 1 plus 1 divided by 1 million raised to the power 1 million, this will be like 2.7. You may choose 10 million. 1 plus 1 divided by 10 million raised to the power 10 million, this will be 2.711, whatever. It approaches to the number e as n goes to infinity is exactly the number e. And the number e is defined like 1 plus 1 divided by n divided by n. So what is this limit that is here? This limit that is here, let's go to write it like limit of 1 plus, let's go to divide numerator and denominator by 3. If I divide numerator and denominator by 3, the expression will be like this. Okay, and now let's go to divide by 3 and multiply by 3 the exponent. I didn't do anything. The only thing that I have done is that now I can recognize the number e. How do I recognize the number e? This is the limit when n goes to infinity of 1 plus 1 divided by n divided by 3 raised to the power n3 raised to 3. But this is e. You see, this is e, because if you take n divided by 3, if you take n divided by 3, if you change n divided by 3, by the number n prime, by n prime, this is the limit when n prime goes to infinity, because when n goes to infinity, n prime goes to infinity, of course, of 1 plus 1 divided by n prime raised to the power n prime raised to the power 3. So this limit, 1 plus 1 divided by something raised to the something, to the same thing, this limit is here, is e. 1 plus 1 divided by something raised to the power something, to the same, is e. So this is e. So this limit is e 3. Okay, this is e. This limit is e. So it will be e3. And the problem is solved. Let's go to the next problem. Determine whether the sequence a sub n equal 4 minus 1 divided by n is monotonic or whether it is bounded. The sequence a sub n 4 minus 1 divided by n, this is the 0, this is the 1, the 2, and the 3, is when n equal 1, it's 4 minus 1 divided by 1, which is 3. So the first term is 3. When n equal 2 is 4 minus 1 half. 4 minus 1 half is 3 half. So a2 is here. Now a3 is 4 minus 1 third. So a3, let me put it in yellow, a3 is here, is 4 minus 1 third. So as n goes to infinity, a sub n approach to 4. So the limit is 4. Now what happened here is the following theorem. When you have if a sequence is monotonic means that is always like this. A sub n plus 1 is bigger than a sub n. It is true. A sub 1 is 3. A sub 2 is 3.5. A sub 3 is 375. It goes always to the right. A sub n plus 1 is always bigger than a sub n. When this pattern doesn't change, we say that we will have a monotonic sequence. Now this monotonic sequence have some special property, and the special property is bounded by the number 4. You cannot go far away from the 4. You can never be at the point 4.1. The sequence a sub n is smaller always than 4. So the theorem say when you have a sequence that is monotonic and bounded, then it will converge. A sub n will converge. And here it's clear that it will converge to the 4, will approach to 4 more and more and more as n goes to infinity. Okay, let's go to the next problem. Next problem says determine whether the sequence a sub n equal minus 2 divided by 3 is monotonic or whether it's bounded. So we need to find the terms. The term is minus 2/3. The other term is 4, 9 positive. Now it's negative. So the terms is not always all bigger than the previous one or all smaller than the previous one, because monotonics means two things. Could be meaning two things. A sub n plus 1 is always bigger than a sub n, or the other kind of monotonic decreasing is that a sub n plus 1 is smaller than a sub n. So in this case, this sequence is not monotonic because it goes, so it will not be monotonic. And it's bounded by 2/3. So if you plot all the numbers, a sub 1, a sub 2, a sub 3, you will see that any terms a sub n, any term a sub n is smaller than positive 2/3 and bigger than minus 2/3. You will see that the a sub n are bounded above and bounded below. So 0, 1, 1/3, 2/3, minus 1/3, minus 2/3. Any terms that you will have is between minus 2/3 and plus 2/3. So they are bounded. The term a sub 1, for example, is minus 2/3. The term a sub 2 is 4/9, something here. The term a sub 3 is something here. The term a sub 4, so is bounded above and bounded below. Is bounded. So what we will write that a sub n is smaller than 2/3. You cannot go far away to the right farther than 2/3 or far away to the left farther in the negative direction of minus 2/3. You can never be here, you can never be here. You are between 2/3 and 1/3. But because the sequence is non-monotonic, it will not converge. Okay, next one, write the 5 terms of the sequence a sub n equal square root of n of n. Square root n is square root, no. The n square of the number n. So it will be a square root of 1 of the number 1, a square root of 2, the number 2, a square root of 3, a square root, no, how do you say, the n roots, this is the n root of the number 1, the n root of the number n, this is a sub n. So for n equal 1 is 1. For n equal 2 is the square root of 2. For n equal to 3 is the third root of 3, the fourth root of 4. And this number, it goes to 1, 1.4, 1.44, 1.4441. It has a limit. It goes to some limits. Oh, this is interesting, how we will find the limit. So a sub n will go like this. A sub n is the n root of n, or n raised to the 1n. So we take natural log of a sub n, and natural log of a sub n will be 1 divided by n by natural log of n. Now we want to find the limit when n goes to infinity. So, of natural log of a sub n. When n goes to infinity, natural log of n goes to infinity, and n goes to infinity, so I can apply L'Hopital rule here. So, when n goes to infinity, the limits when n goes to infinity will be the same limits. That's what to write here. The limits. So we call y n to the 1n. So the natural log of y will be 1 divided by n by the natural log of n. When n goes to infinity, the limit when n goes to infinity of natural log of y will be the limit when n goes to infinity of the natural log of n divided by n. So this is of the form infinity divided by infinity. So we make the derivative respect to the n using L'Hopital rule. So this will be 1 divided by n, divide the derivative of the numerator is 1 divided by n, divided by n. 1 divided by n, divided by 1. We make the derivative respect to n. So if we make the derivative respect to n, the derivative of natural log of n will be 1 divided by n. The derivative respect to the n of the denominator will be 1. So the limit when n goes to infinity will go to 0, because 1 divided by infinity will go to 0. So the natural log, the limit of the natural log of y, remember that y is n to the n in natural log of y when n goes to infinity, this goes to 0. So y, this is the natural log in base e, of course, of y is equal 0. So e to the 0 is y, but e to the 0 is 1. So y represents the limit of a sub n. Y is the limit of n when n goes to infinity of a sub n. So this goes to 1. So at the limit goes to infinity, this sequence will go to 1. So it starts at 1 and n equal go to infinity. It starts at 1, it goes to 1.4, 1.4042, 1.4014, and now it starts to decrease, it starts to come back. As the limit goes to infinity, the point 1.38 will arrive to the point